The authors Stanka Šebela, Izidor Tasić, Čarman Martina, Magdalena Naparusha-Jančić, Uroš Novak, and Mladen Živčić are presenting the title Potential Near Fault Observatory Site in Slovenia, Overview of the area south of Postojna. Slovenia is a country between Adriatic Sea and the Alps, where karst represents 43% of the area. We have more than 14,000 registered caves and numerous surface karst features. In geotectonic sense, Slovenia is part of a convergent margin zone between the Adria microplate and the Eurasia plate. The area is characterized by moderate seismicity. Karst poljes as Planina and Cirknica polje are developed within Adria fault zone, which is supposed to be responsible for 1511 earthquake with magnitude 6.8, being the strongest earthquake in the territory of Slovenia. The proposed Near Fault Observatory site, called Slovenia Karst Near Fault Observatory, is about 1,000 square kilometers big area in southwestern Slovenia, which extends from Postojna to the border with Croatia in the south. This area belongs to the Dinaric unit, which is characterized mainly by subvertical northwest-southeast oriented faults, the most important of which are Idrija, Predjama, Raša, and its auxiliary faults. Green signs are existing national seismic stations. Red signs are the new temporal seismic stations. GNSS stations marked in yellow are part of the Signal National GNSS network. The area south from Postojna is composed mostly of karstified Mesozoic carbonate rocks and partly of non-karstified eocene flysch. Karst landscape has typical underground water drainage. Karst aquifers in Slovenia supply more than 50% of the drinking water needs. Postojna Flysch Basin represents the hydrological divide between Adriatic and Black Sea waters, which is connected with regional active tectonics. The study area holds several karst springs used for water supply and a military training area, altogether resulting in highly impact environmental protection issues. Hydrogeological data as karst underground water tracing connections, spring discharges, water quality are also available for slow karst Near Fault Observatory site. The strongest modern earthquake in this region belongs to Ilirska Bistrica event in 1956 with magnitude 5.1 and intensity 7. In 1926, there was Cirknica earthquake with magnitude 5.6 and intensity 7 to 8, which location might be situated inside the proposed Near Fault Observatory site. In 1995, at Ilirska Bistrica, we registered an earthquake with 4.4 magnitude. Frequent earthquake swarming events are also typical for the area south of Postojna. Because the earthquake locations are not so reliable that they could be attributed with certainty to any known fault in the potential Near Fault Observatory area, the existing national seismic network was recently densified with the new equipment of the project Research Infrastructure Slovenia EPOS, founded from the European Cohesion Fund, to improve the accuracy of the locations and other earthquake parameters. In addition to 4 existing seismic stations, 7 new temporal seismic stations were installed in the year 2020. In this way, moderate earthquakes and seismic swarms can be continuously recorded, which makes possible to detect a weak seismic activity and to investigate the kinematics and dynamics of active faults in the area, and consequently contributes to a more accurate development of the seismic hazard map. The figure shows seismicity of the slow-karst Near Fault Observatory site for the period from May 2020 to the end of June 2021. That has been detected by 7 new temporal seismic stations. We can see the strongest event of magnitude 2.7 on 13th May this year around Snizhnik Mountain. There is also the increased seismicity in the border south of Slovenia and Croatia. Here we can see seismograms of the Petrinja earthquake in Croatia with magnitude 6.2 on 29 December 2020, detected by 7 temporal seismic stations, Risi Epos in the area south of Postojna in Slovenia. Moreover, one very broadband seismic station owned by the University of Trieste, Italy, is installed in the second longest cave in Slovenia, which has 24 kilometers of passages and is called Postojna Cave. The broadband seismic station is situated about 100 meters below the surface and is operating since the year 2010. This increases the dimensions of the complex measurements in the cave, where more years-long data sets of climatic, air temperature, carbon dioxide, methane, radon, humidity, ventilation, and microdisplacement monitoring registered with 4 automatic TM72 extensometers are provided. On the left, we can see extensometer instruments marked with the yellow, and on the right image, we can see the places with microclimatic monitoring in Postojna Cave. We also have detailed structural geological maps for the Postojna Cave and the surface with LiDAR topography. Additionally, to the area of the Postojna, in the area in the southeastern part of Postojna, there are also instruments that are subject to the research at the contact between the Dinaric strike slip fault area and Zagreb Mid-Hungarian shear zone. In this area, the new equipment for very broadband seismic station at Bojanci, situated about 70 kilometers southeast from Postojna, was provided within the Risi Epos project. Data are transmitted to Orpheus as part of the National Slovene Seismic Network stations operated by Slovenian Environmental Agency Seismology Office. In the same area, Kostanjeviška Jama, that is a show cave in the southeastern Slovenia, is also part of the structural geological studies. In Kostanjeviška Jama, we collect data of microdisplacement monitoring registered with extensometer since the year 2008. We have significant vertical displacement of 0.35 millimeters in the period from the year 2008 to the year 2017. Additionally, we also have cave microclimate data, especially air temperature and radon measurements. The new research infrastructure is highly important for gaining new scientific data and products and for realization of the continuous monitoring of chemical and physical processes governing active faults. The research is part of Horizon 2020 project EPOS SP and European Cohesion Fund project operation called Development of Research Infrastructure for the International Competitiveness of the Slovenian Research Infrastructure Space, or Risi Epos operation. Slovenia is part of the EPOS community since the year 2010 and is also one of the establishing countries of the EPOS ERIC. Risi EPOS operation, within which we provided new seismological and other research infrastructures, is important for establishment of the proposed Near Fault Observatory site in Slovenia. In the proposed Slovene Karst Near Fault Observatory scientific cooperation between Slovene scientific community, the organizations as Karst Research Institute, Slovenian Environmental Agency, Seismology Office, Josef Stefan Institute, and foreign organizations as University of Trieste in Italy, ICTP from Italy, and also Institute of Rock Structure and Mechanics of the Czech Academy of Sciences and Arts is taking place for many years. And this shows the international interest for Slovene Karst for offsite in the future too. Thank you for your attention.